Alright, hello and welcome. So in this video we'll be talking about the basics of function in Python, and we'll be going through all that is needed to know to get familiar with functions. So we've been before you just have known about if statements, else statements, loops, conditionals and all of that, and now moving to functions. What are functions actually? Functions is like a device, that groups a set of statements so that we can run them more than once. So we can collect those sets of statements together and then repeat them several times without having to rewrite the whole code. So the main purpose of function is to prevent you from rewriting your code again and again and again. So let's take, for example, when we check out the dir of a string or of a list, we have this. So we can see contains doc. All of these things are functions. Many of them are functions, some are methods. But let's look at example like len. When we call on the len method, the len function, when we call the len function on something like a list, it also works for a string. So when we say 1, 2, 3, and we call the len function on it, we get 3 as the output. So what happens here is that this len is a function that takes in a value. So len is a function that takes in a value and then it returns, and it counts how many values are present, and it returns it. So when we have to do this manually and repeat it again and again and again, it is going to be stressful. Let's take, for example, if we are to create a code that does exactly this, we'll first start by creating a count, and we'll say count equals to 0. It starts from 0. Then we'll say, okay, let's declare a variable. We say something is equals to 1. Is equal to a list. We say 1, 2, 3. So when we say count is equal to 0 and we look through it for I in something, count plus equals to 1, right? So this is the code that is required when we have to print count, right? Sorry, there's a space here. Okay, so this is the code that is required to count how many items are in this list. It also works for a string, it also works for a tuple, but we can't be having to be repeating this again and again and again. That is where function comes in, like this len built-in function. So if we are to create a function that counts this again and again, so we don't have to repeat ourselves, let's assume we want to clone this len function now. So what we are going to do is we are going to start with the def. So what does the def do? The def is the statement. It is a statement that creates an object. So in this situation, what is the object going to be? Count. Just like len is the object here. So count is the object we are creating now. Now count will take in some set of values called parameters or arguments. When we write len here, we put in a value inside. Now count takes in just one value. So we write value. So this value can be of type string. It must be iterable, meaning you can loop over it so that when you want to perform the counting, it's going to be like this. So it takes in a value, which is an iterable. So what does it do after? When we define it, we put a column after it. Then we press enter. This is tab, 4 spaces, right? So inside this count object that has been declared, what do we do now? We write our code inside it. So let me just copy all of this and I put it here. Let me make sure the tabs are correct. So this is the code that is inside the count object. So in this situation, I won't call it object again. It is a function. The object has been created now and it stands as a function. So the last line we need to do is to print count. So what happens here is that after creating your function, anytime, let's leave this here, So anytime you call on that function, we say, anytime we say count value, so you count sum, you know, sum is still constant, we've not changed it. So anytime we do this, we get the output. So let's understand what we did again. We first declared our function called with using the def statement, and we call the name of the function we want to use, count. So you can take this as if you are storing some code inside this count, like storing some things inside a variable, but this is not a variable, do not mix it up. So next thing, we put in some brackets, and then we pass in value, which is the parameter that needs to be used inside the code. So did I use sum here? So it's value I was meant to use here, value. So it's still the same thing, but what this means is that we are using for I in this value here that is passed in. So when you pass in a value like this, it now checks for I in that value, and then it counts them, and then it prints count. Now this part here is the body of the code that is stored inside this. So note that this is the body. Now there's something missing here. Let me add that quickly. So what I just added now is called a docstring. So this docstring, when you use a docstring in a function, you are using that docstring to create like a documentation of what the function does. So let's take, for example, let me illustrate that. So to get what this function does, let me save it first. To get what this function does, we now write this: print count dot underscore doc. So this is what you use. This method is what is used to get the docstring of a function. So when we print this, we should get exactly this: count the items in a value and return the result. So when we try this again for this len, that means len should also have this. So let me copy this and just replace it with len. So when we print this, you can see that it says return the number of items in a container. So that means to say, when they properly wrote this code, this was how it was written. So you can see now that in our code, we did some things now. There's this line that we did here. We printed out count inside the code. And you can see that when we called count sum, it brought out 3. But that is not how it is meant to work. We don't want it to print it out. I mean, when we said learn this, because I'm using Jupyter Notebook, if you are using like VS Code now, when you say learn this and you don't wrap it in the print statement, nothing will happen, you won't get a result. But the only reason we got the result in this situation here is because of where they added a print statement inside the function. I want you to know that. So when you call a print statement inside a function, you get the result whenever you call the function normally. But that is not how a function works only, because learn, okay, now you see, let me now illustrate what I mean by that. When we say number is equal to learn sum, right, and we print number, sorry. So when this happens, you can see this works out well. What I'm trying to illustrate something here. We saved the len sum into number variable and we printed it out. Now let's try the same thing for the count function we created. So if I copy this now and I paste it here, so instead of len, I'll use count. So you can see that we get a different result this time. What do we get first? We first got 3, which is the count. Then we got none. Now, I want you to know that this 3 here is not what is returned by the count. It is just passing this print statement when you call the function. So remember that function is as if you are writing the whole code but packed into one place. So it is as if we are doing count 0 for I in value, count plus equal to 1, print count. So it will print this count. Then this none here means that this whole function we created earlier did not return a value. Now, what does return mean? Let me explain that. So when we come here and copy this again, and we paste it here, okay. Now let's talk about the return value and the return statement. So here now, for us to return the count so that it can be stored into a variable like this, so that when we print whatever is stored into the variable, it doesn't give us none, it gives us this 3 instead. What we just do is say we use the keyword return. Return what? Count. So when we repeat this line here, let me do this, let me save this, and we paste this. Alright, when we repeat this line, what do we get? 3 and 3. Now this first 3 here means that this print statement is the one that is showing this 3. Now this second 3 here is what is returned, which is stored into this number variable here, and it is printing it out as 3. So note that any print statement inside a function will always be outputted normally, generally. But if you don't return anything in the function, it is the default value that is there is none, like what is there now. Okay, so let's continue with this. We note that a function takes in a value. It does whatever it wants to do with the value, and it returns the output, or it might print the output. Now it is not every single time a function needs a value. Let's take, for example, let's say we want to greet. We just want a function that pops up and say greet user. Okay, so when we say greet, so we start the function by saying def, and we say greet. We don't need to pass in anything. We are creating the function here, and we just say return hello. We are not printing hello now, we are returning hello. So when we call the word greet, so when we print greet, because normally if you just say greet here, nothing will happen. I can't illustrate that here because I'm using Jupyter Notebook to print it, whether you tell it to print it or not. So let me wrap this in a print statement. Let me do this then. So when we print greet, we get hello. What happened here is that instead of this greet that is here, it is immediately replaced with this hello, because that is what is returned, right? So you have to know that it's not every time a value needs to be passed. But if we are to pass a value in this situation, let's assume we have a name variable and want to greet that name variable, we can call the name here. Name is equals to Ayo, and we say this greet function takes in a variable name. So I can decide to write name, I can decide to write value. Whatever you pass into this function does not affect what is used outside. What I mean is that if I write greet name here now, this name will be this value here will be replaced with this name I want to take in. So this value just means the input. So we now say return hello plus value. So when we do this, it is meant to say hello Ayo. You can see now. So what we did here is we wrote name equals to Ayo, greet Ayo. So Ayo enters this function, which now goes to this line. Now it now replaces this value with Ayo, and it now says hello plus Ayo. That gave us our result, hello Ayo. It is that easy. So just assume that the value that is passed inside here is not necessarily VALUE. It is just this variable that is passed inside Abi. Alright, so there's also one more feature of function you need to know, that just like we wrote here that we wrote greet and call the braces, whenever you want to call a function, you have to note that you have to put these two braces there. We did it here, we wrote print greet. We did not just write print GREET and we remove this. If we do this, this is what we get. Function greet are this. So this is an object. This is an object, not the result we want. So let's undo it and do this back. Now, you can actually store a function as a whole, not the result, not the return value, a function as a whole inside a variable. Let's say, let's go back to our count. Let's call this counter. Counter is equal to count. You can see this count here now will go here and pick this count object. You know, when we printed the result of this, it goes function this at this. So when we print counter, let me first show you that first. Print counter. You can see it says function count at this. So if we want to now call this for counter now, normally if you want to call counters, if you now want to call the counter, we say counter. They will now pass in the argument there, which was sum, and we get 3. Now this 3 is still being printed out because I still left the print statement in the count function, but that doesn't matter. Let's go further into our code. We notice we've learned some things here, that it is not every time you need to pass in a value, but if you do pass in a value, the value will be used inside the function as you go on. Now, what does this value represent? A function takes in some things called parameters. Okay, just like len, it has to take in a parameter, which might be a string or a list. So that's also what happens to every function generally, but we don't necessarily have to be one parameter. All of those parameters are called arguments. So when we have a function now of add, we want to add 2 numbers, you know, it will take in, you're adding 2 numbers, not if you import the math module, you know, there is sum. Okay, it's even sum too takes in 2 arguments. Some function takes in 2 arguments, some taking just 1, some taking more. So those arguments are called arguments. So those parameters are called arguments, and we can pass in more than 1. So if you want to put add, we can say x, y, and then return x plus y. So x is an argument, y is an argument, and they are both positional arguments. X is placed first, y is placed second. The order really matters in Python programming. It means that when I write print, right, add 1 and 2, add 1 and 2, we get 3. But this one will work perfectly because of whether you put 2 plus 1 or 1 plus 2 is commutative, you still get your answer. But if we try division now, we say def, right, divide, and we say the dividend and the divisor. Note that the names I am putting here are quite different. I put x and y here, I put value here. I can decide to change it to whatever I like. What you are putting here doesn't mean, it just means that okay, whatever is coming in here should represent dividend, and whatever is coming in here should represent divisor. So when we continue with our code, we say def divide, it takes in the dividend, it takes in the divisor. And what happens? We return dividend over divisor. Right. So when we want to divide 6 by 2 now, we say print divide 6, 2. You know, that's the function. We get 3.0. Now, what if we put print divide 2, 6, but we want 6 to divide 6 to divide 2, but we'll put we'll put 2, 6. We get a different answer entirely because of the way function works. Is that the first argument will represent this first argument, which will be used in the code, and the second argument will represent this second argument, which will be used in the code. Now, if a function takes in 2 arguments and you pass in 1, like this print divide now, if it's that we come here and we say we only put 6 there, we get an error. So the error is a type error. So you see, divide is missing one positional argument divisor. So the program understands that, okay, you passed in the first thing. What is the first thing? The dividend. But something else is missing. What is that? The divisor. So as you pass in the dividend without the divisor, you get an error, because arguments are compulsory and they must be passed in, except in some cases, which we will get to. So let's go back to this example that we did there, that we wanted 6 to divide 2, but we passed in 2 and 6 first. What if we want it such that we can put 2 first and 6 second, but at the same time we want 6 to divide 2? In this situation, we have to name it accordingly to this argument here. So we'll say, let me put the 2 and 6 back. So when we have this now, we want 2 to divide 6. We have to explicitly say that, okay, divisor is 2, and then dividend is 6. So when we do this like this, the program will understand that, okay, what you are passing in is the divisor as 2, dividend as 6. Yeah, we stated this directly that, okay, bro, it isn't 2 that is, although 2 comes first here, but it is not the dividend, it is the divisor, as stated in the naming of the argument. So that's where naming of arguments might actually be important. So you might actually, if I will just put some random names there or something, it won't be as functional as this. So when you print out this function now, it runs exactly the way it is meant to run here. So this is what is called positional argument. Now let's talk about, we did addition, we did division. Now let's talk to multiplication, and we'll see how far we can still go with arguments. So let me write the code. So what we did here is we wrote a simple code that multiplies 3 things together. But now there's something that is not right about this code. Although normally when you do run this code, when we say print multiply 2, 3, and 4, we get the output we want, 24. But what if we want to multiply just 2 and 3, just 2 digits, or we want to multiply as many digits as we pass in? Why don't we make it uncountable? Why must we necessarily be stuck with this number of arguments? This is where using the asterisk comes in. Now let me explain what that is. So when we want to call our function this time, we'll say def multiply, right? Multiply. And what are the things we want to pass in? As many arguments as possible. Since we are unlimiting the arguments, we just do asterisk args. No, I want you to note that this args that we wrote here represents arguments, but it doesn't actually mean. We can write numbers. It doesn't matter. But what matters is this asterisk that must come first. This one tells the code that, okay, there are some groups of numbers that are coming in. All of them will be represented as a tuple combined together. So when you want to work with this code, unpack those tuple and then work with them. But it just states this asterisk means that group of numbers are coming together. It might be 1, it might be 2, we can't count. That's what it means. So if you want to multiply this number, we'll loop through it. Normally, let me run a print statement for you to see what it looks like. So when we say print numbers, now let me say multiply 1, 5, 9, and even 3. You can see that what numbers are here is a tuple. It is a tuple and not individual numbers, which means that when we want to make use of these numbers in this code, we have to first unpack it. And now let's do that. What does unpacking mean? It is very easy. We just iterate through them. That is just what it means. So we have star numbers. So if you want to multiply these numbers, we say, let's start with result equals to 1, then we now say for I in numbers, I so we will now say this. What I just did here is that I looped through each number that is coming in. It might be 1, 2, 3, I don't know. Then I multiply them together by multiplying them to results and storing the values. So when we now return results, we get what we want. So when we multiply 2, 3, and 4 first, let me save this, then print this. So what did I do? For I in numbers, oh sorry, it's return times equals to I, not I times equals to result. Wow, was a mistake. Result times equals to I. So when we're here, all right, so you can see it gives us 24. Now we can put in unlimited number of arguments we want, because all it just does is I traced through them and it does this. So we can even decide to just put in one value there, and we say just 3. If we put in just 3, it will just be 3 times 1, which will say 3. So this asterisk, using this symbol and combining the arguments, passing in arbitrary number of arguments, is very, very useful if you don't really need a specific amount of numbers. If you can allow as many numbers as possible to enter. So multiply has worked now based on us allowing as many numbers to enter as possible. So I want you to remember that it doesn't actually necessarily mean this is the only thing also that can stay here. If we say something like def, for example, let's say you want to order a food now, you want one particular topping, then they should mix as many as available that you mention. So what we say is def, let's say toppings, or let's say, okay, make pizza. So the first topping we say important and then any other one that's coming in. Note the order in which I put this. Importance has to come first before this asterisk toppings, because this positional argument is the main one and every other thing comes in. So if you put toppings before importance, you get an error. I want you to know that also. Okay, what we did is we created a function made pizza that takes in the important one we need, maybe the special. I remember maybe we actually use special, and then it takes in all our toppings that are needed, and then it prints in the special first, and then other toppings that are inside it. So when we call this function and we say make pizza, and then we put in the argument we want to put in, like pepperoni. So when we just put in this first argument there and we don't put in these toppings, nothing actually happens. It just prints as it does, as it wants. Preparing pizza special pepperoni. Why doesn't it actually bring out an error? There are two reasons. The first is because it is very what matters the most is this importance, because we are just iterating through this remaining. So when it says for topping toppings doesn't exist, so it doesn't matter. But this importance is the one that matters the most, and it was passed in. If it's that we passed in an argument. Now now we passed in a group of things here. We say, okay, pepperoni, mushrooms, so when we pass in all this group of arguments, the first thing the code does is to pick out this important. Is it present? Yes, it is present, and it picks it out that okay, the importance is pepperoni. If we made mushroom the first here, it will take mushrooms as the first. Let me just show you that. You can see preparing pizza, special mushrooms. If we want to explicitly say that okay, green peppers or extra cheese is the special, we are going to do what? We are going to have to say it here and say important is equals to extra cheese. This is because of the argument important, according to what we have saved here, is what? The argument important is the first here. And this asterisk toppings means after important, every other thing is a collection. But here we said that important is cheese, but at the same time we gave this collection. This is a keyword argument, which we'll still talk about, but these are groups of a collection of arguments. Let me put it that way. So in this situation, if you actually want extra cheese to be the first one, if you put it in the front, it will still give you an error. Let me show you that. You can see it says positional argument follows keyword argument. What this actually means is that this cannot come first. Whenever you assign a value to the name of an argument in the calling of the function, this has to be last. What we did the other time was the correct method, but it did not match what we did here. Okay, to check default value, let's write a function that finds a square root of a number. We say def root. It takes in the number, right, and it takes in what it should be squared with. So let's say the root. So it should return the num raised to power the root, right? So if we say root square root of 4, and because of the square root we have to put in 2, we get 16. Raised to power, that was a mistake. I'm going to use what is exponential? Raised to power 1 over, sorry, So when we find the square root of 4, we get 2, and this actually works well, except that the default square roots, when we use our calculator, we don't necessarily have to be putting 2 there. It is only when we want to use something else, like raised to power the cube root or raised to power 4, the fourth root or things like that, we have to put in. So why don't we have a default value for this root instead of us having to be passing 2 every single time? That is where default values comes in. So let's write our code again. So in this situation, we'll call the default value for the root 2, such that if you don't pass in these 2 inside the calling of the function, what the program does, or what the code does, is that it already assigns a default automatic value that, okay, if you don't pass in anything, use this. So let's find the square root of 4 again, as we did, but this time we don't pass in 2. you can see it gives us 2.0. If we pass in 2, it will still give us 2.0. But if we are trying to find cube roots, let's find the cube root of 8. So when we pass in 3 here, you can see it gives us 2.0. Now this 3 here overrides the default root that is here and makes use of it when this function is called. So that is what default values are just about. If you have something that doesn't necessarily need to be imputed, you can put it like this. So now what we're going to create is an intersection calculator, which is going to check intersection between two values, maybe a list and a list, what are common between them, a tuple and a tuple, a string and a string. Let's do that now. So what we did here simply is we created a result, an empty list called result. Now we iterated through the first value 1 for I in value 1, and we checked if that value is in value 2, the result should append that I. It is that simple. So let's save this. When I say intersect, right, of 1, it takes in 2 values, right? So you can say a list 1, 2, 3, and what? 2, 4, 6. So when we print out the result, it gives us 2 because 2 is the only thing common between 1, 2, 3 and 2, 4, 6. Now when we try this again for 2 strings, but this time the cases are different, but they're the same thing actually. So what do we think we get here as a result? So we can see that they are both the same, but we get just capital letter P and small letter m as the result. Why? Because of Python is case sensitive, right? So when it was iterating through value 1 and it saw capital letter S is not in capital letter S here is not the same thing as lowercase s here. So all it did is that it only filtered out those that are match exactly the same casing, like P here and the M here. So why don't we create a function such that we can tell a user that, okay, do you want this thing to be case sensitive or not? So what we just do, we just pass in an argument, a keyword, which has a default value of true. So like this, okay, so like this now we have sensitive equals to true by default, right? So as it is true, this happens. But what if it is false? So if not sensitive, so what I did here is that we check if the user passes in sensitive as false, it should turn both of them to the same case and then work with that. So in this situation now, if we pass in again this first thing, because of we're working with numbers, you might think, oh, we did .opy to give us error, but it won't actually, because of numbers don't matter in casing. You can see it still gives us 2. But when we try this again now, it gives us P and N because we do not pass in any argument. So let's pass in sensitive as what? False. We don't want it to be case sensitive. Let it, okay, you can see that all of them are the same thing, are the same when they are case insensitive. So that is what default value also comes in, and that is where I introduce you to keyword arguments. The keyword arguments are not that complex. They are just very simple. What they mean is that when you are passing in a keyword argument have key and what and values. So when you write a function, you can pass in keyword arguments into the function, but it doesn't actually matter. Sorry, what did I say? When you write a function, we can pass in keyword arguments. Like instead of us just saying false here, we can decide to write sensitive is equal to false. It means the same thing. So sensitive here is the keyword that has the value false. So let me quickly explain what keywords are. So keywords are like name, as I just said, key value pairs that you pass to a function, and they are matched by the argument name. So when you put in sensitive equals to false, it looks for what sensitive is and passing false. It is just like, where were we? So you can just think of it that, okay, keyword arguments are like combination of default statements and any other thing. But in this situation, sometimes you need to actually pass in the name of the key. So let's, just like we did here initially here, that we said that when we passed in multiple arguments at the same time, we used one asterisk. If we are to pass in many keyword arguments at the same time, we now use what is called double asterisk. This is how it's going to be like: double asterisk, star keyword args. You know, as I said, this can actually not mean keyword args, it can mean any other thing. So let me comment this out to prevent error. Okay, so now we are going to combine them together, right? So the code we are going to be doing is now a profile builder. You should collect the data from the user. From what we have done now, it will collect the data from the user, and it is going to print out, build a profile, a dictionary of profile for that user. So we'll start to declare our function. So we'll call the function name build. Let me just call it build, although it's build profile I wanted to write. So now let's use some compulsory arguments and some positional arguments. So let's say what is required for us is the first name and the last name. Please note, this order actually really matters. Keyword arguments come after positional arguments, and even after this asterisk here. Let's assume we have first name, last name, some other things that I might want to pass, and then the keyword arguments. This is what the keyword argument is now going to be like. You can see us putting just one asterisk or us putting asterisk and args, they are the same thing. So what I just wrote here means that we are calling a function build that takes in two compulsory positional arguments. The first thing that is coming in should be the first name. The second that is coming in should be the last name and some other things. And then it will bring in some arguments which must have key and values. So what these args mean is that if you don't pass in key and values together, you should just pack all of them together as a tuple. And what this keyword argument mean is that if you are bringing in key and if you are bringing in key value pairs, you should take them out as a dictionary. Very, very straightforward. Now let me write the code. So I want to follow the protocols we've been explaining since. So let's see. So we have a docstring here called build. Which is build a dictionary containing user details. That's what the docstring does. So let's create a dictionary, an empty dictionary here, profile. So first name and last name are compulsory. So in the profile, we add key and values to them, saying first name, and then so we have made use of the first name passed in and the last name passed in. So any other thing you pass in will just be wrapped out at the keyword argument and are rendered invalid. So because we're not making use of them, we're not doing a calculator in this scenario, but in some cases might make use of them. So why don't we say any other argument that is passing, like the middle name, the age, the place of birth, the workplace, and things like that. So what we are going to do is iterate through the keyword argument. Remember, it is a dictionary, and to iterate through dictionary, we do for key value in keyword args. Okay, let's us use keyword args this time. Let's use other details, or so for in other details. Right, for key value in other details, what should happen? The profile should create a key with the name of that key that is coming in and a value. So I hope you understand this. This is just a dictionary, looking through a dictionary. So after a profile does all of this, you should do what? You should return the profile. Very easy. This is just what we need to do now. So I hope no error. Okay, none. So now let's build our dictionary based on, let's build our profile based on just our name. So when we just pass in Ayo, we get an error. Alright, you can see it is missing one required positional argument last. So we have to pass in it in, and I just want us to get as many errors as possible in this. So we have this Ayo and then mix. So when we pass in just these two arguments, let's see if we get an error. No, our profile is being built because keyword arguments and these other arguments are not required. If it is required, it will be passed in as well, first and last. That is what it means here. So we have our build containing just first name and last name. Why don't we add something useless? So when we say, let's add our age, but we don't write it in form of a key pair, we just put 12. What happens? You can see our name is still built. So what this 12 here, remember, means is that it is passed into a tuple of these args. So it doesn't mean, so let's even, if args, print args. If sorry, that shouldn't be there. Okay, so let me save this again, and then I come here and I run this again. So you can see it passed, it just soaked it in and it did nothing with it. Now our keyword args, on the other hand, let's do this. So maybe we should ignore the 12 or we should put the 12, doesn't matter. But let's say our age itself, sorry, this one you don't need to put what is it called there? Let me see. So it is as if you are putting in a variable. You can take it like that. Okay, that you are creating a variable inside the function name, and when we pass this in, what do we get? Get an error. Too many values to unpack, expected 2. So that is meant to come from for key value in other details. Too many values for key value in other details. Oh, I've forgotten where I iterating through a dictionary, so it is dot items. Where is it? So, or even the commenting is actually not needed. Where is it? Let me undo the first two comments I put here. Sorry for the confusion here. So I just remember that we are working with dictionaries, so this is what is needed, dot items. So remember dictionary, what we have to do is just put dot items here, and that should work. So this args that we removed the other time is actually not necessary to remove. I actually forgot. Too many values to unpack. So when we pass, let's try the previous one that gave us the first error. So this shouldn't give us an error again. Build takes 2 position argument, but 3 were given. Okay, I have not saved it. What a message. That is not saving, just not saving was the problem. So even this line is meant to work now. I think it will work. It should work. Let me undo this part. When we run this, it does work. I don't know. Sorry for the confusion actually. Just saving can be very annoying sometimes. That is why VS Code comes in very usefully there. Okay, so we have this now. Let me refresh. I'm sorry for all of the mistakes I made now. Let me refresh. When we call our function, we've called in the first argument, the last argument. These two are the positional arguments. Then this asterisk args means every other thing that is not associated with key value pair, that is not a dictionary, that you just pass in single as an argument. Now this double asterisk other details is every other thing that are key value pair related. So when we started with this example, we said build just IO, and IO represent the first here, but we didn't pass in the last argument, so we are going to get an error saying missing one required argument last. So the next thing here we try to do is we built our names with those two required parameters only, and we got our profile built. The third thing we then did is that we passed in an extra positional argument, but because it is not a necessary argument and it is not used in the function, we just called it to be printed out, but the profile is built based on the two important arguments we passed. So the next thing we now decided to do is to pass in all of them together: the first argument, the last argument, the unrequired argument, and then the extra keyword argument that we pass in. So you can see what the output is here. And yeah, so the last thing I want to talk about functions now is understanding the global scope and the local scope. See, if we print the sum that we used initially here, you see that 1, 2, 3 has not changed. All our writings and our programming we've been writing since. This is because when we defined sum initially here, you can see when we define sum, we defined it globally. This line is not inside a function here, is not inside anywhere else. Like the count we used inside function len. This count now is because I've defined count before, so if I print count, it will print the initial count of count. Let's say we call this thing something. We call it any other thing. We can't access this value. Let me even show you now. We can't access the value outside of the function. Why? Because of the body of a function is called the local scope, while the body of your code of the module itself, of your Python file, is the global scope. Let's say for now, let me not use count here. Let me use count here. Let me change this one to go. Doesn't matter. Go. So after we write this function and we save it, right? So when we say print go, we get an error immediately. It says go is not defined. Although you might have defined it inside the function, but that was defined locally, so it is not a global. It's sorry, we did not. It is not a function. Sorry, we define this variable go inside the function. You get an error because it is not a global variable. How do you identify global variables again? They are variables that are called outside of a function, that are not in between anything like this. They are just independent on their own. So what if we want to make this go global such that we can access it outside of this function? We use the statement global. It is a statement, so global. So we say global go. So when we save this now and we come to this line and print go, we can see, oh, what did I do again? The only reason this didn't work is because we've not actually called the function itself. You know, it is a line by line this thing. We've not called the function. So let me just call count. What is this? Let's say count the number of words in hello. So you can see that counting, let me remove this print statement here. Let me save that. Also come here and save this. So count hello is not going to return anything because we did not print it explicitly. But print go is going to return something because we've used the global statement to make this thing seem as if, or should I say seem as if, I don't know if it is a wrong word to use, but it is as if this go was defined outside and was modified, and the result still remains constant. So global, I think global itself is self-explanatory. It means that it can be accessed globally anywhere in our function. Let's say, for example, we have let's do this. We have global name, and we say name equals to Ayo. So is there an error here? No. So when we print name here, we get Ayo normally. What if we call a function that modifies name? So we now say def greet. It takes in an argument name. Okay, it doesn't even take in an argument. Let's not let it take in an argument. So we now say name is equal to name plus an exclamation mark, and we return name. So when we call the function greet, you can see that it prints. Oh, sorry, why is this hello here? Where did it come from? No one told you. Oh, sorry, that greet went to meet the initial greet. Let's use another thing called user. Let's say user here. I've not saved this again. What is the problem? Cannot associate local variable where it is not. Okay, so yeah, we have to explicitly state. So you using global name in this situation doesn't actually work, but it is in this situation you use global name. I will now say name equals to the normal name. I got a mess. I hope it doesn't cause an error. Okay, so you can see now that when we say global name and we say name equals to this initial name plus exclamation mark, and we call user, it gives us this. Now let's print what name now is. You see, name has changed because of we wrote this global scope here and we modified the value of name. Now this might get a little bit confusing. I'm very sorry for not explaining it well, but let me use another example. Let's say def something, right? Something, and when you call this something, it creates a variable age and it assigns 5 to it, right? So let's make it a global something, global age, and then this function does nothing naturally. Let's just leave it like this, it doesn't matter. So anytime we call something, normally you see, before we call something, we say print age, we should get an error unless I've called age before. Okay, age is not defined. But when we say something, then we now print age. You can see age is now 5, because when we call this function, it executes this line global age, which means create a variable age which can be accessed outside of this function and then store it as 5. So that's what function is basically all about. We've talked about the local scope, which I said is this part inside the function. We talk about the local variable, is the variable name defined inside the function if this global is not there. Let's go up. No. Like this, I've assigned too many things to variables here. Like the count we did here initially, it cannot be accessed outside the function because it is a local variable inside the local scope. Sum that we defined in it when we started writing this code is a local is a global variable defined in the global scope. We can also define a global variable in a local scope by using global. It is that simple. So let's quickly revise. Let's just run through in a minute or two and just understand what we've done so far. So functions are everywhere. We have built-in functions, we have imported functions that you can import, and we have functions that we can create by ourselves. We created a function count which takes in an argument and it adds, it counts how many numbers, how many times, and it counts how many items are in the function. We also checked the doc, which is going to print out the documentation, or how would I put it, the doc, what the function is about. We talked about arguments, keyword arguments, positional arguments, and also passing in arbitrary number of arguments. We talked about returning values. We talked about the default value of a function is none. We also talked about passing in argument by actually stating the name of the argument. For example, in this division scenario, we talked about passing in the default, assigning default values to arguments, like when we created intersection here and we said sensitive is true, which is the default, and we worked on that. Then we did the whole build calculator, which we encountered so many errors in, and I want to apologize for that. At the same time, I forgot to save. So we did all of this and we combined all we learned together by taking the first name, last name, which are positional arguments, args, which are any other thing that are not key value pairs, that are like positional argument but are not stated, and it takes in other details which are keyword arguments. So that's about it. That's about the basics of functions. That's just what this video is all about, talking about the basics of functions. You know, there are 3 other things in functions that we haven't talked about at all. We have the nested functions, we have the factory functions, we have anonymous functions like lambda, mapping, filter. We have the non-local statement, which is entirely different from local scope and local variable. We also have recursive functions. We have functions in functions, and things like that. But I'm not trying to scare you here. Once you understand the basics that I've just talked about here, every other thing is going to be seeming very simple, and you don't actually need most of those I just mentioned now. You don't actually need most of them. This is the basic. This is what you need. This is what is going to prevent you from rewriting codes again and again. So in my next video, we are going to be creating a Roman numeral calculator, and we are going to be making use of functions to convert numbers to Roman numerals and vice versa. So I'm going to drop the link in this video when the video is deployed. If you don't know much about Python, if you want to learn more about Python, links are in the description. This channel is providing resourceful insights on Python programming generally. So I'll see you in the next video. Mix out.